Hi, I'm Mike Bloom. I'm an AI solution architect here at WEKA. We're here to talk about the infrastructure behind generative AI. Let's talk about multi-cloud infrastructure for LLMs. The current landscape of multi-cloud generative AI workloads is marked by significant complexity, driven primarily by the challenges of managing large-scale data across multiple hyperscalers, such as Azure, AWS, Google Cloud Platform, and Oracle Cloud Infrastructure. One of the most critical factors contributing to this is data gravity, which refers to the difficulty of moving large data sets due to their size and the associated costs. In the context of generative AI, data gravity manifests in two primary areas. Training assets for generative AI models require vast amounts of data for training. This data often spans petabytes, and moving such massive data sets across different cloud environments can be costly and time-consuming. For instance, training data might include large collections of images, text, or other media that need to be processed in a GPU-intensive workload. The result of a GPU workload after running AI training jobs, such as trained models or the intermediate outputs, also needs to be managed effectively. And while these data sets are typically smaller in size, gigabyte scale, they pose challenges in terms of storage and accessibility, especially when different cloud environments are involved. Organizations adopting multi-cloud strategies for their AI workloads face several data management challenges. Costs. Moving data between different cloud environments incurs significant egress charges. When you move data outside of a hyperscaler, they charge you for it, which can quickly escalate when dealing with large data sets. For example, transferring data from AWS to Azure or GCP can be prohibitively expensive. To avoid high transfer costs, organizations may duplicate data across different clouds, leading to consistency issues and increased storage costs. And the geographical distribution of cloud data centers can introduce latency in accessing data, affecting the performance of AI workloads. Some organizations centralize their data in a single cloud-based data lake and use that as a hub to serve multiple AI workloads across different clouds. This approach minimizes data movement but can create a single point of failure and bottleneck. Others replicate their data across multiple clouds, ensuring that data is readily available whenever the AI workload is executed. However, this can lead to increased cost and complexity in maintaining data consistency. Organizations also leverage on-premise infrastructure for data storage and processing, combining it with cloud resources as needed. This reduces reliance on any single cloud provider, but introduces additional management overhead. The WEKA storage platform offers a robust solution to these challenges through its hub-and-spoke architecture, which leverages S3 object stores. In this architecture, a central S3 object store, we call the hub, holds the primary copies of training data and resulting AI models, while each hyperscaler, for example AWS or Azure or OCI, runs WEKA storage software, and it acts as a spoke that can interact with the central hub. WEKA's snap-to-object capability provides a critical role in optimizing data management. Instead of moving entire data sets, WEKA allows organizations to create snapshots of just the training data and just the model data sets. These snapshots are then pushed into object store and significantly reduce the amount of data that needs to be transferred. By transferring only the necessary snapshots, for example, petabyte scale training data and gigabyte scale model data, organizations can minimize egress charges associated with moving data between clouds. The snapshot-based approach ensures that data is readily available across all clouds without the need for constant, costly data transfers. This reduces the data movement overhead and ensures that the AI workloads can access the necessary data with minimal latency. In conclusion, the WEKA storage platform hub-and-spoke architecture combined with its efficient snapshot capability provides a powerful solution for managing the complexities of multi-cloud generative AI workloads, mitigates cost, and enhances performance across hyperscalers.
Thanks for watching AI Demystified. See you next time.